Hello everybody, this is Thierry Couturier from Eddyfi, based in Paris office in M2M. So welcome to this coffee break. And so you see, I'm currently at home in my garden, and I do hope you will enjoy this presentation, which is about corrosion mapping. With Eddyfi, I'm in charge of portable equipment for PAUT like Gecko and Mantis. So let's go. What is going to be presented today is corrosion solution we can offer. So the first one is regarding the Connex mapping that has it's a new scanner that is going to be launched very soon, in which we have a phase array probe with local immersion technique. And then we also have I will show you a second solution, which is the R-scan array. Some of you may already know. And both includes the Aqualock, which is composed of a probe holder and a phase array probe with local immersion technique, so with water column from 15 to 30 millimeters height. These two solutions I will show you with the Mantis and its capture software. So the Mantis I currently have here is the new housing of the Mantis. So it's the electronic inside is the same, and it's something which is about to be launched very soon. And it's a new housing so that you can perform corrosion inspection, well inspection on site in an industrial environment. It's quite a light unit and at the same time robust. We hope so. So with the setup I have will come is with this probe, a phase array probe 7.5 megahertz, 64 elements. So pretty well known for those who have used similar techniques from other manufacturers maybe. The pitch of this probe is 1 millimeter and elevation 7 millimeter. We have also another solution that is available using exactly the same stuff, same probe, same R-scan array, which is the motorized solution with the RMS scanner. It's not something I'm going to present you today. Maybe have you already seen that. So let's start with the Mantis and the scanners. So I can maybe show you my setup. So next to me, I have, so you can see my hand. I have the Mantis, new Mantis, which is close to the Gecko. So I put the Gecko here just so that you have an idea of a comparison about the size of each unit. So the Gecko is connected. So there is an Ethernet connection. It's connected to my laptop so that I can share my screen with you. So you will see what I do on the Mantis. In fact, I can do it either on the Mantis or on my laptop. It's what I'm going to do. Then on that I have a corroded plate. Okay, yeah, and on that, at first I have a scanner, so I can show you the Connex mapping scanner. So it's a new scanner that is going to be launched. So this one can embed the scan the Aqualock. So we have the foam so that we can keep water inside. From the top here we have a phase array probe, and we can just unscrew this and remove the probe to remove the Aqualock. Quite easy. We have magnetic wheels coming with, here we have a brake on both wheels, very easy to lock. Then we have only one axis, one encoder, so on the wheels, because we have a button that can be used to increment the y-axis thanks to the software. So it means we can perform a 2D scan with this pretty simple scanner. Okay, what else can I tell you? So we can unlock also this very easily and slide if we want, remove, and then again, very easy to lock with these simple levers. So what I'm going to present you now is a scan we can achieve with this scanner and the Aqualock. And then I'm going to switch to capture software. Okay, so if I move to capture software, then I can go back to home. So what I currently do on my laptop, you can see this on the screen here as well. Okay, so let's start from scratch. Okay, so that you can see that preparing a setup takes only a few minutes. So the way capture software is organized, we have different menus at the top, and we need to go through the different steps to have a complete setup. So the first is equipment, and in equipment we have specimen. So the plate I'm going to inspect, I can select the probe and the scanner. Select the plate at first, and I can give a geometry. So let's say my plate is about 500 millimeter long, 300 millimeter wide, that's good. Thickness, so measuring this with a caliper gives me 7.5. And the weld, so I could have a weld, but without any weld, of course. Then I can either I select the velocity because I know it. In this case, I know it, so no need to calibrate. But because there are some procedures with which you are asked to calibrate, and then if I put a bit of water, then you should see sooner or later some echoes coming up. So here I have also maybe something I did not show you. I have a small bug sprayer here, and then I can put a bit of water. Yeah, water is coming. Okay, then if I want, I can have some echoes, and I can select the different types to calibrate, considering the peak or the first flank. Depending on your inspection procedures, you might be asked to use first flank instead of max peak. In this case, I have no cal block here, quite accurate. So, and then I cannot really calibrate on that for sure. So I can keep these parameters, which are very good at first. So my specimen is done, and then I can go to next step and select the probe. So here I need to select from Silverwing the Aqualock with 7.5 megahertz. Water column is about 15 millimeter, but I will measure it. So if I edit, I can go through these different steps. 7.5 filtering. Most of the time, I like using low pass. It's a good way to get maybe some cases sharper echoes, but in fact, it's really up to you. I keep all these parameters which are correct. Dicing here, it's more for information. And then I have a wedge, and I will use angle, go to reference and height calibration, so that I can measure the height. And this is so if I move my probe, you see it's live signal, and I can measure, and you see the wedge height is 19.15. What we can see here already is that the probe is very parallel to the surface of the plate we are inspecting. So because the way we hold the probe allows to have something perfectly set up. So 19.1 millimeter In fact, I will go to wedge, tell the software it's L0 degree and keep 19.1 millimeter. So now my probe is set up. Which scanner I'm going to use? I'm going to use my Connex mapping. Okay, I can edit it. So it's 49 points per millimeter coming from the encoder. And here you can see that I have selected automatically, everything is saved in the database. One axis scanner plus increment. And each time I press the button, have a look to increment. Okay, I have some increment. Then I can check that my encoder moving the right direction. Scan is positive, that's fine. I'm ready with the scanner. Then I can follow the arrange button and click on next. And the next step is focal law settings. I can edit, select linear scan, L waves. With this probe typical setup, we use 6 elements. So it gives me an equivalent active aperture of 6 by 7 millimeters, which is quite good for this kind of setup. And then, so I start from element 1 to 64. This means I have here 59 different beams. The coverage is 59 millimeter. Then focusing. In fact, with such probe 6 by 7, I don't really know where my focusing point is. Natural focusing, which is the near field distance of this probe, is maybe further than the area of interest, and I don't want to use this beam in the near field distance or near field zone. So what I can tell the software, maybe if I give 3 millimeter as a focusing point, I know that plate is 7, so from around 3 millimeter, I am perfectly safe, and my UT beam will be very good. So then I can compute, put a bit of water, still perfect, and then I can see I have some live signals. Okay, great, good. So I can accept this step, and with these focal laws. Now next step is gates. So with gates, right now I want to have my G1 gate that will be synchronized on my interface echo. So the first step here is I will set up my interface gate so that I can always detect, so I can do it with the mouse as well, or the touch screen. Okay, at maybe let's set up something at 50%. And then once I have this, every time, so I can check on the scanner on the left here that my interface echo is always in the gate. Then if I press on, now my interface echo is always detected in the gate. And then my G1 gate will follow the interface echo. So then if I move my gate, let's say 3.5, because my procedures say I don't need to go closer than that, even everything which is below 3.5 has to be detected, and that's fine. So that's my gate. I can keep this one, 50 millimeter, 50% as well, and why not add in one more gate on the first flank as well. So I must check that. Yes, my gate here is max peak. I must be consistent to have something accurate between the gates. Some procedures like or recommendation given by OIS says that you need to use first flank. Good. G1 is first flank as well. G2 as well. Great. And then I can. Okay. Might be here. I can start at 9.5. Okay, enlarge my gate a bit. Good. Then my gate setup is pretty good, and what I want now is to use calibration, and what I like is to have a quite nice detection, even if so it's always a matter of compromise between the gain and sensitivity. I don't want to have too much noise, but it's good to have echoes which are of a high amplitude enough. And what I can here set up is a small TCG, so that I can have the same shape on the echoes, especially because I use also the first flank measurement. I need to have quite nice echoes. Okay, so if I I can add another point maybe on the thickness. So probably I would need also a cal block to achieve that. But here I think without any cal block I can also have something maybe 8-10 dB. Let's see what's okay. Maybe I can reduce the gain a bit and then add one more point on 15 millimeter, maybe a bit, yeah, 4 dB more. Okay, yeah, or modify maybe a bit more, 16. Why not? Okay, you will see that it gives so some pretty good results. If I want, I can save this. I can override this probably. I can save this TCG in case I need to reload it quickly instead of entering this point, entering manually this point. I can load this TCG again. Then that's my calibration, and then I press orange button. Next step is motion. So in motion I have reference. So here if I move my probe, okay, now I can reset my, okay, so that maybe I have my first beam on the edge of my plate here. I can then change my offset 29.5, which means half of 59, and then the first beam is at 0 perfectly. Okay, okay. Then I can tell the software how long I want to inspect. So let's say here I want to have yeah, 300 or so, and then here so my steps will be 59, corresponding to 59 focal lows. I can have maybe 3 steps, so 3 times 60, 180 millimeters, for example. Good. Okay, and every time I will press the button, I will probably, you see, increment the position of the probe. Good. So this is good. Then display, I think I already have something displaying eScan AS. What's there here? AEDC. Yeah, maybe I can change that. Yeah, some call also A, B, C, D. But I can create new layout. I can save. I can open predefined layout if I want. Okay. Then recording. This is the last step. So here I will enter so corrosion maybe with connects. This will be my file name with automatic naming saved in data files. Good, maybe yeah, corrosion folder. All the data are stored, and then I apply a bit of compression. I don't need so high resolution. I can keep high resolution if I want. I can compress more. This is there. Once here, I can go to inspection, and then if I put some water, yes, okay. Okay, so then I can try to go to a start position. Okay, and reset. And I'm ready to scan. Then I can press the stop button, and then I don't need to touch anymore the software. I will just move. Okay, so this is good. Once here I can move by 59 millimeter, 10, 20, 30, 40, 50, 59, and press the button once, and then put a bit of water and scan backwards. Oh, okay, this data. Okay, another 59, 20, 30, 40, 50, 59. Press the button, bit of water. Good. Okay, another 59. 1, 2, 3, 4, 5 centimeters plus 8. Increment. And then scan. Okay, so this is done. Okay, I missed some data here, not that much. File name is okay for me. I can press OK, and then here is what I can get. So I can zoom if I want, and so I will not go through analysis. So maybe this will be done in another session. I can at least show you what we can get to prepare a quick indication table. So I can move cursors so that I can encompass the area where I have some corrosion. And in that area, then I can display some readings. So we have 8 readings available. If I click on it, I can prepare and change this list of readings. Here I select something we have predefined, but you can do it yourself with a lot of different values, with different parameters. You have some information where what you have selected. And between the cursors, right now I have selected that values that are given where the minimum thickness is detected. So minimum thickness is 3.8, detected at 50 millimeter. So if I move my scan at 50 and my index at 95.5, this is where, yeah, makes sense, where the minimum thickness detected. So then I can use this button to add this as an indication in the report. Then I can move to another maybe indication. Let's try with this one. So let's say I have 2 areas here, one here and one here. Again, in this area, I have so 60.5 is the minimum thickness here, and along scan axis to 31. Okay, Yeah, it makes sense as well. So I can add this as well, press OK. What I want to do, in fact, I can maybe keep something, a different layout, select my different other layout, and keep a screenshot of this one. So maybe I can call it corrosion, whatever you want. And then display in my indication table. So I have two indications, but I want to be sure that my setup is correct. I can load a pre-existing indication table, okay, in which I have for each areas where the area starts, its length, on scan and index axis, what is the minimum depth, and then the material loss, corresponding material loss. It has been detected on first flank in gate 1, and I can attach my screenshot to G1, and maybe I can consider both of indications need to be rejected and press OK. And so the last step is generating the report. So just to show a quick example, what would be a typical setup of a corrosion. So I can see my Aqualog, the Connex mapping software, the parameters, gate 1 and 2, TCG, indication table with the screenshot attached to a second indication. So I know it's a bit quick, but in fact, it's you will be able to review this coffee break later on if you want. And then you can export a PDF, okay, so that then you can afterwards have this PDF available as a report. So this is what we can achieve with this Connex mapping scanner. And what I want to show you now is we have the RScan array. So I can remove, in fact, my Aqualock from here, my Connex mapping. Just remove my encoder, release my Aqualock. Okay. Then I can just put my scanner on the side and then use my Aqualock. Pretty easy to set up. Just give a bit of pressure, lock, connect the encoder. Right now, quite easy. I can attach these cables together. Okay. Good. And then if I go back, so my setup is almost ready because I have not changed at all my Aqualock. It should be more or less the same. So if I put a bit of water to fill in the water chamber, yeah, still plenty of water. Okay, well, good. Everything is there. What else? Oh, yeah, I need to go back to equipment because I have not the same scanner. So Silverwing, this is the RScan array with which I have a different resolution. And again, I have a scan axis, one axis plus increment. And I also, so I have two buttons on the RScan array. one will be pause and play. You will see why it's useful. And the second one for increment as well. So let me check if so you can see at the bottom it's going backwards, so I can change the direction of the encoder. Yes, good. And then I just need to go back. Yeah, I'm asked to go through configuration again. A quick test. Okay, so if I reset, okay, then if I press the button, okay, steps perfect. Good. Maybe yeah, now I will not use Connex, but it will be rscan array. Oh, yeah, corrosion rscan as a file name. Inspection. Then I go to the start position. Okay. Then reset everything. Put some water without any air bubbles. It should be okay. Perfect. I can in fact leave water flowing, but reducing. I have a small tap to reduce the flow of water. And go. Okay. Once there, I can pause, then go back, because I don't know how to move by 59 at this end. So now it's much more convenient. 59 millimeter. Then I press the blue button here once to have increment, longer to have a reset, and pause, and then scan again. Good. Seems the data stitch together. So pause again, go back, plus 59, 7. Okay, increment, reset, play, go with a bit of water. Great. Pause, back, 13 to 19 almost. Increment, reset, play. So you can see I can have the same, exactly the same display than what I had with Connex mapping scanner, but it's more convenient with a scanner. No need to go back exactly the same location, same position. It's easier, but in some cases access is limited. The rscan array can be used manually still. Okay, then I can save. And this is basically what I wanted to show you. We have these two solutions available, and that gives pretty good results. And so that's the scanners. The last thing I would like to show you is regarding the Mantis. I told you that the Mantis, in fact, or maybe I did not tell, we have three different options. The first one is a 1664 PR, which is very good for corrosion mapping. You can have a linear scan. And the second one can perform weld inspection with, as you have it with multi-group. And fully compatible, we have also the Connex weld, which is coming, on which you can have two phase array probe and Toft at the same time. And then in this case, it makes a good package for thin welds, basically into medium welds, multi-group, Toft phase array. That's the second option. And the third option is with a TFM64 with the Mantis. So you do not have PWI on this. It's more on the Gecko, but at least you can have a PWI, and then it's something I can show you in case with corrosion mapping. Then on top of that, you need to characterize, have more information about your corrosion. Why not use TFM and the Mantis? So in fact, I've prepared here, so I have exactly the same parameters, the specimen, then the probe, the scanner remains the same. The main thing, the only thing that is going to change is TFM. So if I set up, so here I've prepared something. My zone is 50 millimeter, 8 millimeter, starting at just below the surface, using L0 mode. PWR is not available. Then using 64 elements. So I know that this probe is maybe not the best to perform TFM because I have a pitch of 1 millimeter with 7.5. So I know I can get some noise, but at least we can get something, you will see. So if I adjust this, okay, we have something which is not very nice. Maybe I need a bit of water. Okay, and maybe here, in fact, I have used the default parameters of the wedge, and it's something I'm going to check. Right now I have 18.7, and I can go to angle height, and maybe I can measure. So you see I have 19.46, so it's more than almost a millimeter. So if I do it now with this new height, so go to settings and TFM and compute again, maybe my result is going to be, in fact it's a shear waves, I need L waves. Okay, see, and now we can have some quite nice images. Okay, so in case you need to perform TFM, you can do it with your Mantis still, so it's an option. And for sure, if you want to perform a scan which will be fast, you have some fast option here, but I think it will give you in this case more bit noise, you see. So it's always a matter of compromise. You can change the number of elements if you want, so you really have access to different parameters. Okay, still. And in fact, fast will be a bit 3-4 times faster because in fact the acquisition rate can be quite low. So depending on the scanner I set up. But if you really want to perform an acquisition with a scanner, then maybe the Gecko will be faster. Keep in mind the Gecko has 64 pulsers, so you need to pulse once to collect 64 signals back to build your FMC. If you do it with the Mantis, as it's a 1664 unit, you need to pulse 4 times. So definitely the Mantis will be slower than the Gecko. But at least for characterization, when you don't need to scan, it can be a good option. Good. So that's what I wanted to share with you today. Our scan array mapping, connects mapping with the Mantis. And then you see manual water pump with the Aqualock capture software. Everything is there for your corrosion mapping. That's it for today. So if you have some question, do not hesitate to ask any question. So I know there is a bit of delay between the time I talk to you and the time you listen to me. You can hear me, 20 to 30 seconds. So don't worry, I will be waiting for your questions for at least 30 seconds, and maybe you will watch this not live. So here you can see my email address. Do not hesitate to email me your questions, and I can also share the data files with you if you want. So some questions are coming regarding the scanner. What is the maximum length of the bars that I can have? Ah, yes, okay. So currently we have in mind to have something up to 500 millimeter scanning width. But it's a good question. In fact, if you let me know what do you think the good length, the right length or width would be. So definitely it has to be a compromise, but we can probably offer different option. Here we have about yeah, 400, so we can go much further for sure. Another question: is there compatibility of the hydroform probe with the Aqualock or R-Scan? Yes, okay, the probe itself, yes, is compatible. So if you already have the hydroform, you can use the R-Scan array and the Aqualock with your phase array probe. Yes. Okay, another question. When the Connex scanner is going to be launched? I think the Connex scanner is to be launched probably end of June, beginning of July. So it's very close. And keep in mind we have Connex weld and Connex mapping that are going to be launched probably more or less at the same time. Then what's your scan speed in TFM with this setup? Okay, let me check what is my scanning speed. I'm pretty sure it's slow. You see, it's about 11 millimeter per second. So if I pressed on fast, yeah, 4 times faster, 40 millimeter per second. So now maybe we can have perform a quick scan. If I go to configuration, edit, okay, can keep this, display, can have something simple. I have a T-scan, C-scan, D-scan, okay. Okay, keep this, inspection, and then you can see that I can have okay, need a bit of water as well. Okay, and then if I reset and just on one line at least, it's negative, so I can just stop. Then I can just change the direction of my encoder. Okay, inspection, reset, scan, a bit of water. So here I have a gate that is probably amplitude, but if I switch to depth here, but you see we can scan. Still possible to scan without losing too much data. Of course, my in this case my TFM is not very nice. It's fully normal, and probably I would use Sorry, I've been told you don't see my screen. Sorry for this. Okay, so I was doing, in fact, a scan. I can do it quickly. Okay, going back. You see it's live. Reset, scan, and then I can scan. So if I go too fast, of course, I lose some data. And here it's with a fast mode, which does not give the best results. But if I go to settings and use the best standard FMCTFM, then I know I will have something much nicer. And in this case, it will be really nicer for sure. But I must scan very, very slowly. Okay. If I go too fast, then I miss some data. Other questions? How light is the new mantis? So it's, I think it's about 3.7 kilos. It's quite light. Yeah. Good. So no more questions. So you have my email address. I hope you have enjoyed this presentation. Just send me an email and let me know how you feel with this kind of information. Thank you very much for attending. Bye bye, everybody.